In the vast expanse of our universe, there exists a dream that has captivated the human imagination for generations, the dream of journeying to the red planet Mars. From the early stargazers who marveled at Mars in the night sky to the monumental achievements of Apollo that first took us to the moon, the exploration of Mars has always been a beacon of human ambition. Today, that dream is closer to becoming a reality than ever before. With groundbreaking technology, international collaboration, and unwavering dedication, we stand on the brink of embarking on a journey that will forever change our understanding of the cosmos. Join us as we delve into what the journey to Mars would truly be like. From the challenges of space travel to the scientific discoveries awaiting us on the Martian surface, this is a voyage that will define the future of human exploration. NASA currently has a well-defined plan for safely transporting the first humans to Mars and ensuring their safe return. Let's delve into the details of this ambitious endeavor, often referred to as the space race. The initial phase involves establishing a robust and enduring presence on the moon. While it might not seem drastically different from Earth, transitioning from the moon to Mars is notably easier than heading directly from Earth to Mars. Earth's gravity and thick atmosphere are conducive to human life, but restrict the quantity of cargo that can be sent into space during a single mission. In contrast, the moon does not present these limitations. Despite the challenges of living on the moon, overcoming these hurdles opens up the moon as an ideal spaceport, essentially a gateway to the broader solar system. NASA's Artemis program represents a long-term commitment to this objective. This time, returning to the moon isn't just about planting flags, as before, but rather focuses on comprehensive goals. Artemis missions 4 through 10 are aimed at mastering lunar living, including the use of local resources such as water and oxygen, found on the moon for constructing infrastructure. Concurrently, NASA and its partners are working on the Lunar Gateway Space Station, positioned in cislunar space, creating a launching point for Mars exploration. As NASA establishes a human presence on the moon and in the lunar vicinity, they are also actively expanding their robotic presence on Mars. This expansion includes the deployment of new rovers, but the real excitement in the next decade lies in the widespread usage of aerial vehicles on Mars. With the successful trial of the Ingenuity drone, it's confirmed that we can indeed fly helicopters on Mars, opening up an array of opportunities for exploration and sample collection on the red planet. NASA is even contemplating deploying an autonomous space station in Mars orbit, serving as a semi-permanent way station not only for missions traveling to Mars but also for those returning. An essential component of future Martian research will be sample return missions, signaling the end of one-way trips to Mars. This encapsulates NASA's overarching moon-to-Mars strategy, setting up a foothold on the moon, acquiring the skills to thrive in the harsh lunar environment, exploring Mars extensively, and creating a foundation of robotic missions for future human arrivals. With all these elements in place, we are now ready to embark on our journey to Mars. Even before humans reach Mars, one or more cargo supply drops are slated to ensure that everything needed for survival and the subsequent return journey is pre-positioned on the planet. The process initiates with Artemis 10, in which the Space Launch System delivers a payload called Mars Cargo Stage 1 to lunar orbit. The cargo includes propellant for the return ascent, a power source for the crew, and mobility equipment. Furthermore, an ascent vehicle is placed on the Martian surface before the crew's arrival. The pivotal moment arrives with Artemis 12, where the Mars 1 human lander is transported to the Gateway Station. Departing from the Lunar Gateway, the transit habitat will embark on its journey to Mars, likely returning to the Gateway Station at the conclusion of the mission. The mission's core event revolves around 2 astronauts landing on Mars inside a pressurized vehicle, designed to function both as a living space and a rover for their 30-day stay on the Martian surface. This dual-purpose habitat and rover ensure a smooth transition for the astronauts as they reacclimatize to Mars' reduced gravity after months of weightlessness in space. To transport individuals from Earth to Mars, NASA is developing a transit habitat employing a combination of chemical and electric propulsion stages. Landing on Mars presents its challenges. NASA's recent Perseverance rover mission provides insight into this process. The rover entered the Martian atmosphere within a capsule. Despite Mars having a thin atmosphere, it's sufficient to require a heat shield to shield the craft from burning up. After penetrating the upper atmosphere, the Perseverance mission employed a massive parachute to decelerate its descent, while the capsule autonomously selected a landing site and maneuvered using gas thrusters. The unique aspect is the later stages, where the parachute alone cannot provide a soft landing. Instead, the rover disengages from the capsule, equipped with a jetpack to control the descent. This phase requires propulsion for a controlled descent to a hover, followed by the jetpack. The exact method for landing human missions on Mars may vary, but it is undoubtedly a complex endeavor. There are two mission profiles for Mars journeys: short stay and long stay. In the short stay mission, the outbound journey lasts for 217 days, utilizing a gravitational assist from Venus to propel the spacecraft towards Mars. The stay on Mars lasts for 30 days, and the return journey extends for a challenging 403 days in deep space. This extensive duration is due to various factors, but it provides an opportunity to make the mission safer by minimizing time spent on Mars. In total, this mission spans 650 days. Conversely, the long-stay mission involves an outbound period of 210 days, proceeding directly from Earth to Mars without gravitational assists. During this extended mission, the crew stays on Mars for 496 days. The return window is shortened to 210 days as the crew capitalizes on an optimal transfer opportunity. It's important to note that this plan aligns with the current available technology, but NASA is actively developing a next-generation propulsion system to expedite Mars transit. Both NASA and DARPA, the Defense Advanced Research Projects Agency, are collaborating on the development of a nuclear thermal rocket engine, often referred to as Draco. This technology, expected to be ready in under 5 years, offers the promise of significantly reducing transit times for human missions to Mars, potentially from 8 months down to just 45 days. This acceleration is critical in mitigating risks related to extended time in space, including exposure to cosmic radiation. Additionally, it reduces the need to carry excessive supplies, such as food and water, given the significance of minimizing payload mass in space travel. The emergence of Draco marks a crucial step to realizing the goal of building the first Mars transit habitat. While our path to Mars may be without clear directions, it is this very uncertainty that fuels our human spirit. With each step we take, we are guided by our unyielding curiosity, boundless imagination, and unwavering determination. Don't forget to like and subscribe so you never miss a space update. Until next time, farewell.